The primary challenge that we were addressing is manufacturing robots in a very accessible way, very cheap, very quick.
And so we were looking for alternative methods to bring a full electromechanical system together. And one thing that we saw is that Origami can produce very complex structures.
Assembly by folding is not only inspired by origami, but it's also inspired by natural systems, ranging from unfolding of leaves and insect wings to protein folding. There's lots of examples you can look for and then try to embody that in folded devices. That required us to think about the materials involved, the manufacture of this composite structure, and a lot that has to do with the design.
And so one way to do this is to make a flat composite. You have flexible print circuit boards. You can make them out of paper and polystyrene. Polystyrene is sold commercially as shrinky dinks. And simply put it through a laser machining system and come out with a fold pattern. And then you take your composite and fold it up into a functional machine. And what we do is we mechanically pre-program this composite with features at each hinge, which tell it how far to fold along each line.
This work is in large part supported by the National Science Foundation. One of the elements of this bigger picture vision that we're pushing together with our collaborators at MIT is to have a complex robot do something useful, yet have it not be assembled by experts. Basically, it just assembles itself. This demonstration is the first machine that leverages folding to assemble itself and then do something, in this case, walk away.
Now that we've demonstrated that self-folding can be used to build functional machines, we think this can be applied to a variety of different problems.
Deployment in harsh or exotic environments like space or battlefield, deployable structures that we could put in difficult to reach places.
In addition, it could do for machines the same thing that Kinko's did for home press.
The work that we've recently demonstrated, we feel, is an important aspect of this, because we can show now that we can take relatively straightforward requirements, walking in this case, then translate that to a flat design, translate that to a set of recipes to assemble this structure, and then press a button and it builds itself and walks away.